Hey guys, TJ Schwartz here in the Schwartz Knife Shop. Today I want to talk about knife sheaths. That is Kydex knife sheaths, vacuum formed, how to do it precisely, how to design them, at least how we do it. I hope you guys enjoy. So here we have an Overland X sheath. It's very similar to our Overland Sport sheath, just slightly different size. And so a lot of the features are very similar, and we'll just talk about one of these today. So these are in-pocket sheaths mainly. You can see how they come with an ulti-clip. Big reason for that is this knife is adequately sized to fit inside most pockets, and that seems to be the way most people carry them these days. There's a couple design features I have integrated for the in-pocket ability of this sheath, and that is the flat mouth here. A lot of sheaths and sheaths we've made in the past will have a bit of a cutout here so that when you reach forward, your finger is in the actual index position on the knife. The problem with that in the in-pocket is that when the knife is going in, the pocket brim is probably going to be somewhere up here, and you're going to have an exposed area where the edge of the knife is going into your clothing without a sheath, and that's not ideal. So you can see we've got a flat mouth here, and next we're going to talk about some of the retention features. So one of the things that I really don't like about some sheaths is sometimes a knife can be put in, and if the edge digs down into the bottom of the sheath, where if you can imagine the two pieces of Kydex being laminated, it's going to start pinching the edge if the knife is too far down in the sheath. Of course, when it's going in your pocket, it's hard to tell if it's doing that and sort of aim it. So what I've done here on this sheath is that when the knife goes in, you can see the front of the handle has more or less 45-degree angle on it, and it contacts basically a 45-degree angle ramp in the mouth of the sheath. You can see right there the front of the scale striking that sloped angle, and what that does is as I push, it's going to move the knife up in the sheath. So if you come in far too low like this and you're running the risk of binding the edge down into the bottom, then that ramp is going to drive the knife up. See how as it goes in the sheath, it's guided. So that feature right there allows this thing to lock into the next stage of being placed in the sheath, because it's been ramped up. The edge is no longer going to be catching, and on the spine side of the knife, you're rarely going to see the catching effect where it's binding, because you have a flat surface going in there and you're not seeing the edge drive down into the valley. And so that little ramp there is a feature we put in that really improved our sheaths a while back. So I just want to point that feature out. And then you can see how there's a low spot in the sheath right here that's going to come in behind the edge of the guard here, and you can see how it jumps over. The knife wants to jump over that little triangle, and that little triangle indents behind the handle itself, which holds it in. And as you can see, we have absolutely zero rattle on this sheath, and that's partly because this is pinching here. And in pinching, it's not necessarily just touching, it's actually has a bit of spring pressure. So you can see on our sheaths here, this is open right here. There's actually a gap, and that's because the sheath is a little bit undersized, so that when the knife's in it, the springiness of the Kydex is retaining the handle here. And then at the tip, we actually have it pinch as well right at the tip. So the sheath is actually undersized right at the tip, and everywhere else along the blade, it's oversized, so the actual slot is much larger than the size of the knife, so that on the way in and out, you have quite a bit of rattle. You can hear it in there rattling, and so you're running much lower risk of scratching a blade on the way in, and then right when it comes into park, it clicks in here and binds at the tip. So you can actually see, if you look close at our sheaths, there's a little bit of a line, and that's where the size of the sheath gets really skinny and actually undersized right here, creating tip retention. So if you have retention in 2 points with the triangle pushing this upward and with a pinch at the tip, you'll get no rattle. And the other way is just to have really fine retention across the whole blade. That's going to cause a lot of scratching. So we find this to be the nicest sort of average of all features. Now, Kydex does have a tendency to scratch blades from time to time. It is sort of inherent in Kydex, so you can't completely eliminate it, but this is as good as I imagine we could do from what I can tell. And from there we have, eyelets around the perimeter that are spaced in various ways. You can have the ulti-clip at various depths. You can have it at this next location where the knife would stick further out of your pocket or deeper in your pocket. And then we have nominal hole spacing here, so you could put any manner of things. You could have 2 loops, you could have something for a horizontal carry, you could put a tech lock on it. I try to keep to nominal hole spacing. So the other thing we have is a thumb ramp. So when you're sticking your hand in your pocket or on your belt to grab this, it's nice to not have to pull on your pants when you're pulling it out. So having a platform where you're not just ripping on your pants trying to get it out, you're actually pushing off, is obviously an important feature, especially for in pocket. So that sort of covers the design of the sheath. Aside from the drain hole, I will mention that this is a massive drain hole. The drain hole you'll see is a lot smaller on most sheaths. A lot of people ask, what is it, blood groove or something? There's all these weird questions out there. The purpose of that is for clean out. So if you run your sheath out in a sandy or dirty environment and you get sand in the throat, you're crawling around under your truck and get gravel in there or whatever, if you don't have a big enough hole for that stuff to make its way out, you cannot get it out, because once it falls into this sheath and becomes wedged, there is not a way to get it out. I made a large hole, A, for the drainage, but B, you can stick the nozzle of an air compressor in here, or you can actually run water through it. So you can stick this on the end of your faucet and let the water pressure kind of drive through there, and then blow air dry it out or whatever you might need, or even put like a toothpick in there. So that's the purpose of that, is for water drainage out in the field, but mainly for clean out. So this is Steven. He's our lead sheath guy, and he's over here cranking these awesome sheaths out, checking for quality, finishing edges, and making sure everything's nice. What's up, Steven?
What's up, guys?
So I was going to show you, he's going to run through some sheath making process, and I was just going to kind of look over his shoulder. I asked him first, so we're good. I'm going to look over his shoulder and show you guys how it's done. So we have our vacuum mold here with our vacuum line hooked up, vacuum pump down here with a foot pedal, so he can press on that foot pedal, turns the vacuum pump on, which pressurizes. You can see a gauge here, or not pressurizes, the opposite of that, creates a vacuum through this hose. I did explain this in our previous video, but we have a layered piece of aluminum and HDPE, which is cutting board material, and we have the negative of the knife sort of butterflied apart, and you can see how we have our retention features built in with a bunch of little holes that pass through the HDPE and distribute from this point so that they all get charged with the vacuum. You really can't see the holes in this white material, but they are there. So we also have a t-shirt press. This is like an Amazon special, nothing crazy. We have temperature set to 370 for 44 seconds. I'm showing you guys all the details. And so he's going to put it in, timer's going to start. So timer starts to count down. There is a heat plate and there's pressure, and this creates the most even heating that we've been able to get. I think we've been really happy with it. What do you think?
Definitely. Yeah, it's much better than the old skillet we used to use.
Yeah, we had a few different kind of hacks figured out before this. We do have some paper on it. It's like parchment paper, stuff you'd wrap meat with in the freezer or whatever, because the Kydex will stick to the hot plate if you don't have that paper in between. And it's not wax paper. Wax paper will melt. It's parchment paper. There's a difference. So you can see the timer counting down. It's going to beep, and we'll see how he does it. So you can see the really soft, melted, nearly melted Kydex going onto the mold. He started using this just heavy vise we had because he likes to be able to walk away to the machine while this is cooling down. And so it's kind of, it works. You can sit here and hold it, or you can walk away and leave something heavy on it to keep the seal. But you saw he put kind of a picture frame around it that holds it down. And I'll show you that once this cools down a little bit closer. That happened really quick. All right, so it's cooled for what, about a minute, 90 seconds, something like that. And he could tell it was cooled off because we've found that when the Kydex takes its set and gets like close enough to room temperature that it's firm, that gauge that's reading the vacuum will start to bleed off, because it's almost like the Kydex can't seal against the HDPE once it hardens anymore. And so your vacuum starts to disappear and you can hear the change of the pump. And so that's kind of his tell, it seems like, as to when it's done. And like I said, it's only about a minute. He did spray a little bit of water on it. If he caught that, that just accelerates it a little bit. Just a little bit of water really will accelerate cool down. So you can see a picture frame that is used to make the seal. And that Kydex is sealed around what's a rectangular boss. You can see it a lot better now that there's Kydex on it. And you can see the definition of everything that we want out of that sheath. It's filleted into the two halves, of course. And we've got the rectangle, and you can see the skirt that would seal underneath this when you put pressure on it. So this thing is ready to come off, and we will show you what we do next. So here's our fixture. It's in a Tormach CNC mill. It wouldn't take much of a machine to do this. Even a router might pull it off. We like the precision of CNC machining after the vacuum forming. Helps with retention and eyelet location and all that. But you can see that we have the same rectangular boss that's on the vacuum mold on this fixture. And that's because when you press the Kydex over this boss, different colors of Kydex will expand and contract at different rates. And when you put it on this surface, it sort of stretches it and pulls it in the exact manner that it was molded, and it kind of removes the warp. So when he puts it on there, I'll let you see. He's actually tapping it on there, and that will stretch the Kydex into its exact position where it was meant to be. Again, Kydex distorts a lot. It depends on the color and it depends on the temperature and all these different variables. So this has given us a really reliable, repeatable situation. Now he's also got a magnetic little U-shaped piece. There was 3 magnets in the fixture on each side and 3 magnets on each side of this. So you can see how it holds it down, and he's going to go ahead and hit cycle start for the first op. So we've just got a pretty standard end mill. It's going to go do 4 holes, and it did the 4 holes only because those 4 holes have threaded holes beneath them. So he's going to thread the bolts in. That's going to hold this in place so that when it perimeter machines each side, it allows this whole skirt to just fall away and these stay in place. It's going to go do each and every hole, all the remaining holes. The machine is now doing the perimeter. So we got the 2 pieces that have been vacuum molded and machined, and from here he's simply going to start pressing in eyelets. So it's that quick to have a constructed sheath. Now we do quite a bit of edge finishing after this. We have just the machined edges on the sheath. We like to sort of blend those together, and we'll show you that next. But the actual construction, when you have the right vacuum mold and the right fixture, can be very efficient and very precise. So if you can imagine this cell, there's 2 stages back and forth, and we've kind of got it where the wait time is similar enough that one's cooling down, one's machining, cooling down, machining, cooling down, machining. And it's a real cool one-piece flow. Every knife is getting tested. We have multiple testing knives with different handle materials. We have found different handle materials have a little bit of different friction. Micarta generally has less retention. G10 generally has more just because of the texture. And so he's kind of setting the upper and lower boundary of retention by testing both handle materials on every sheath to make sure that something hasn't changed, because temperature changing, Kydex thickness changing, precision of the machining changing, even as far as how hard you press the eyelets changing, can affect retention. And so he's testing every single one with G10 and micarta. So this is what the machined edge looks like. not amazing. You can do a better job with a machine, but it's never going to be exactly seamless from a machine. Instead of really pursuing a better machine finish, we've just done hand finishing on these. So what he's doing is taking this to a green Scotch-Brite flap disc. It's what we found works best. And he's going around the perimeter, and when you actually rub Kydex on a wheel like that, it gets hot enough to actually melt a little bit. And so those two pieces, the seams, almost sort of glue together and sort of become one piece at the edge there. So he's doing that, and we'll show you what it looks like. So this is the finish after that high-speed wheel there. You can see how it's all become kind of one solid piece. And that isn't the finish that we send out of the shop, but that's stage one. So what he's gonna do after the rough finish is, you can see he's taking it to this same style of wheel. This wheel is spinning extremely slow, and we wanted this slow wheel and found the easiest way to do it was to get a drill press. And a drill press has generally a belt system to go to very low RPMs. So we're running at the lowest RPM, which is 300 RPM that this can run. There's not really a grinder on the market or something like that that can run 300 RPM direct drive. Pretty much everything has to be some sort of belt pulley, and this is a very inexpensive way to do it. So we have a chuck mounted wheel holder that we got on Amazon, I think, and that real low RPM puts basically a satin finish on the perimeter of that sheath. And because it's not going so fast that it would melt it, you don't end up with a whole bunch of shiny spots, because that wheel, it will gloss parts of it and then matte other parts of it, and it gets irregular. And so with a speed it's that slow, without the melting and heat generating of that wheel, you get a very consistent, even finish. So it's basically satin, and it's a little bit lighter colored on the edge until you hit it with oil. We oil every sheath after this. So he's wiping it down with mineral oil. We choose mineral oil because it's food safe. It's actually something you could drink if you wanted. We try to only put non-toxic stuff on any of our knives. These are sort of food prep knives. You know, you can use them when you're camping to cut apples or whatever. And WD-40 is probably not the end of the world, but we went away from that a long time ago, and we apply mineral oil. So let me go over and get a better angle here. So you can see the edge, how you have a satin finish. It's not a high gloss and not matte. It's kind of a grain satin finish, and the oil really brings it in to match the color of the rest of the sheath. And there we have it, a finished sheath. Nice job, Stephen.
Thank you.
So all of our sheaths are made in a similar manner, but I would be remiss if I didn't show you our LT5 sheath, because we've done something cool here with the drop rig. That's what we call this here. We really want this belt carrier to really hang a little bit lower so that long handle's not in your rib cage. And so these can be made out of Kydex and all different types of materials, even leather, but we make it out of stainless steel. This is a proprietary part of ours here with the leather as well, with the Schwartz embossed there. And I just want to show you that. This is a bigger version of the sheath, made the same way with a different attachment style, and super durable and very, very handy. So that's a really quick rundown on how we make sheaths. Probably missed a whole lot. There may be some questions. If you have any, ask them in the comments. A lot of people ask about our sheaths. People like the retention on our sheaths, it seems like. So I thought I'd help you guys out if you need it, or maybe somebody could help us out if you can see something we could improve on. And I appreciate you guys watching the video, supporting us. If you own one of our knives, thank you very much. If you're thinking about owning one, I hope this pushes you over the edge and you have learned a little bit about what makes our knives special. Thank you, guys.